Hello, Algebra 2, and welcome to your Topic 5 test review. So during this review, I'm going to do several problems that are going to be extremely similar to problems from your test. And then for our next class, I'll be assigning you a review to work on your own that will actually have the solutions as well, so that you guys can work through these, use these examples, and check your answers, make sure that you guys are on the right track. So without further ado, let's get this thing going. So the first thing that you're going to need to do is to graph a function and explain how it compares to the graph of the parent function. So what we know about this, right? We know that this guy right here is a horizontal translation, right? And if it's negative, it actually pushes it in the positive direction. So this should translate it 3 units to the right. We also know that this guy right here is a vertical translation, right? And what does this do? It shifts it, so it's a vertical translation, and it's going to translate it 3 units up because it's positive. All right. All right, but don't just take my word for it. Let's go ahead and get out our graphing calculator or graphing utility, whatever you happen to be using right now, and see what this thing looks like, right? We're going to compare it to the graph of the square root of x. So here is the graph of that particular function. Let's look at it. Let's look at the graph of the square root of x as well. So we'll go down here and put that in and graph it. And there we go. Let's compare some points on this thing, right? So we have a point 0, 0 here, right? Where did this point go? It went 1, 2, 3 units to the right, and 1, 2, 3 units up. So if I need to graph this thing, then I will put that point on there, right? So 1, 2, 3, 1, 2, 3 right there. And it's going to look approximately like that. And there we go. We have graphed it, and we have described the translation of the graph from the function f of x equals root x, and f of x equals the square root of the quantity x minus 3 plus 3. Let's do another one. All right, let's go ahead and simplify this expression. All right, here we go. So in order to do this, I like to split these up into 2 separate fractions, ratios, if you will. For the first one, I'm going to simplify this fraction, right? 8/6. Both 8 and 6 are divisible by 2. And if I divide them both by 2, then I get 4/3. The next thing I'm going to do is I'm going to apply this rule that tells me that if I have some a to the m over some a to the n power, that is, the bases are the same, then I can write this as a to the m minus n power. So let's go ahead and do that. That is times x to the 9 minus 4 power. Continuing on, I'm just going to go ahead and do that subtraction, right? 9 minus 4 is 5. And this would be my final answer. Another one. Okay. Let's go ahead and simplify this expression, right? I'm going to use 2 separate properties here, right? That is that if I have some a, b to the m power, I need to distribute that m to a and to b. That is, I need to raise both a and b to the m power. The other property that I'm going to be using here is that if I have some a to the m all to the n power, I have to multiply those exponents. So let's go ahead and do that. It'll kind of happen all at once, right? 2 squared is 4, and then this is going to be x to the 4 times 2 power. So this becomes 4x to the 8th power. All right, let's get another one in. Let's write this expression in exponential form. So the property I'm going to use here, this property actually goes both ways. I'm going to write it both ways for you. It tells me that if I have some nth root of a to the m, I can write that as a to the m over n power. Likewise, right, if I have some nth root of a to the m power, I can also write that as a to the m divided by n power. And that looks like the situation that we have here. So let's go ahead and apply that property. So this is going to be, and in parentheses, so important that we keep this guy in parentheses, because that 6r is the whole thing, right? The 6 and the r are getting cube rooted and squared. So then I'm going to write this as 6r to the 2/3 power using this property here. All right, let's move on. Okay, let's simplify this expression. I'm going to go ahead and use rational exponents to simplify it. But first, I'm going to use this property that if I have some nth root of a times b, this becomes the nth root of a times the nth root of b. There are other ways to approach it, but this is the way that I prefer. So let's go ahead and do that. We're going to break this thing up like Kim and Kanye. There we go. 4 to the 81st power times the 4th root of x to the 4th times the 4th root of y to the 8th power. Now that I've got that done, I'm going to do two things. I'm going to find the 4th root of 81. We could do that in our calculator quite easily, or we could just think it out. And then I'm also going to go ahead and use a property that tells me that if I have some nth root of a, I can write that as a to the 1 over n power. All right? So without our calculators, you could put the 4th root of 81 in your calculator just fine. It would spit out the same answer that we'll get. But let's reason through it, right? What number times itself 4 times is 81? Now, 81 is a fairly low number, right? So I would think about 2, 3, or 4, right? Because 4 times 4 is 16 times 4. That's a pretty big number, right? Or if you were to get to 5 to the 4th power, it's going to be much larger than 81, right? So 2 times 2 times 2 times 2, right? That is not big enough, right? We know that 2 cubed is 8, and 8 times 2 is 16, not big enough. So let's check 3, right? 3 times 3 is 9. 9 times 3 is 27. And 27 times 3, that's the 4th one, turns out to be 81. So what does that mean? That means that the 4th root of 81 is 3. So now the next thing I'm going to do is write each of these as rational exponents, right? So this is x to the 4th to the 1/4 power. And this one is y to the 8th to the 1/4 power. I'm going to use my property that tells me that if I have some a to the m to the n power, that is the same thing as a to the m times n power. So that 3 is just going to stick around there. And this becomes x to the 4/4, right, when I multiply. And this one becomes y to the 8/4 when I multiply those two exponents. Next step is just to do some simplification of those exponents, right? This is 3, 4/4 is 1. So x to the first power is just x. We'll just leave it. You can write that one there if you want. It's not necessary. I'm not going to write it there. That y to the 8/4, right? 8 divided by 4 is 2. And this can't be simplified any further. So this is indeed our final answer. All right, let's keep this train rolling. Ooh, now we need to find an inverse, right? What is the equation for f inverse of x? Remember, as we learned this, I walked you through some steps, right? The first step is, instead of f of x, right, we're going to substitute y. And the next thing I'm going to do is I'm going to let y equal x, and I'm going to let x equal y. In other words, I'm going to switch these, right? Instead of a y, I'm going to put an x, and instead of an x, I'm going to put a y. Last step is to solve this equation for y. So the first thing I want to do is add 4 to both sides. It's going to get rid of the 4 on my right side and add a 4, a positive 4, on my left side. All right, y is almost by itself. It's got an 8 there. It's multiplying y, so the way that I'll get rid of it is by dividing. That's going to cause those 8s to cancel out because 8 divided by 8 is 1. And there we go. The last step I'm going to do is I'm going to write it using this function notation. So f inverse of x is x plus 4 divided by 8. And this is our equation for the inverse of x. We are just rolling through. Let's tackle another one. Oh, we've got some x and y values for f of x. Let's find the value f inverse of -8. So, first of all, let's write this as the inverse, right? So if I wrote a new table for this, what the inverse does is it flips my y and my x, right? So this is going to become -8, 1. The next one will be -6, 2. The next one will be -4, 3. And then we'll have 2, 6, 6, 8, 10, 10, 30, 20, and then 52, 31. So this here is f inverse of x, if this one is f of x, okay? Just flipping or reversing all of our x and y values, right? The input becomes the output, and the output becomes the input. So if I want to find f inverse of -8, right? It's what this is asking me is what is our y value when x is -8? And the answer is right there, right? Y equals 1. Which means that f inverse of negative 8 is equal to 1. All right, we've just got a couple more to go. Well, 3, I think. And let's go through it. We're going to go ahead and solve this equation, but we must check for extraneous solutions, okay? So remember when we went over this in class, I told you the thing you need to do first is isolate the radical, right? So if I'm going to isolate this radical, I got to get rid of this 10 that's on the left-hand side of my equal sign. So in order to do that, I'll add 10 to both sides. So this is going to give me the square root of x minus 7 equals negative 5 plus 10 is 5. Now that we have our radical isolated, we need to get rid of it. We're going to square both sides, right? So this is going to be x minus 7 squared equals 5 squared. Squaring that x minus 7 does what we really needed, was to get rid of the radical. And 5 squared is 25. Lastly, let's add 7 to both sides. Right, 25 plus 7 is 32. But that's not all. I need to make sure that that is indeed a valid solution by plugging my answer back in. I need to substitute 32 back in for x. And then making sure that I have a true statement here. So negative 10 plus the square root of 25, right? 32 minus 7 equals negative 5. Is negative 10 plus 5 equal to negative 5? For sure. And we're good. So the next one we're going to do, we're going to solve another equation involving a radical. But this one's going to be slightly more complicated. Let's do it. Here we go. So step number 1, isolate the radical is done, right? We only have a radical on the left-hand side of our equal sign. So we don't need to do that step. That step has already been done. So what we said the next thing to do was to square both sides. So let's go ahead and do that. We're going to square x, the square root of x plus 7. And this is where we need to be ultra careful, right? We can't just square x and square 5. I have to square the entire quantity. Oh, that should be a 5. I need to square the entire quantity, x plus 5. Squaring that radical on my left-hand side takes it away because it's a square root. And then over here, I'm going to rewrite this, right? X plus 5 squared is not x squared plus 5 squared, but it is x plus 5 times x plus 5. The next thing that I'm going to do is go ahead and multiply out these two binomials, right? I'm going to multiply x plus 5 times x plus 5, right? And x plus x times x is x squared, and x times 5 is 5x, while 5 times x is 5x, and 5 times 5 is 25. Let's go ahead and just combine like terms over here on the right-hand side of our equal sign. And now it looks like I have a quadratic equation that I need to solve. And every single time I need to solve a quadratic equation, I need to set it equal to 0. That is, I need to have 0 on one side of my equal sign and everything else on the other side. So how am I going to do that? I'm going to go ahead and add x to both sides. And I'm going to subtract 7 from both sides. And I'm going to do that all in one step. So 10x minus x. So this 10x minus x is going to be 9x. And then I'm going to subtract 7 from both sides. And 25 minus 7 is 18. The next thing I do is just cross my fingers and pray to God that this thing is factorable, because I would much rather factor than use the quadratic formula. So if that's true, if it is factorable, then it must be true that there are two numbers such that when I multiply them, I get 18. And when I add them, I get 9. And we can thank our lucky stars that there are two such numbers, right? Those two such numbers are 6 and 3. So that means that my potential solutions are x equals -6 and x equals -3. I say potential solutions because there is a chance that one of them is extraneous. So we need that, right? We need to check for extraneous solutions. Let's go ahead and do that. I'm going to go ahead and plug each of those values into my original equation. In other words, I'm going to substitute them for x. So let's try -6 plus 7, the square root of that. Is that equal to -6 plus 5? So is the square root of 1 equal to -1? No, because the square root of 1 is 1. And 1 does not equal -1. So I'm going to say this guy is out. Maybe I shouldn't be so rude and cross him out. We're going to say that this one is extraneous. Now we can't automatically count x equals -3 in. We got to check that one too. So let's go ahead and go for it. So -3. Is it the case that the square root of -3 plus 7 is equal to -3 plus 5? So is the square root of 4 equal to 2? And it sure is. And so while I do get two solutions when I solve, the only one that is not extraneous is x equals -3. Last one, I believe. Yes, indeed. All right. So we've got a word problem or a story problem, is what the old folks say. Let's figure this thing out. It says that the formula v equals the square root of the quantity 2g times h gives the velocity v in feet per second of an object after it falls each feet accelerated by gravity g in feet per second squared. If g is approximately 32 feet per second squared, find how far an object is falling for each of the velocities given below. And in this case, we're just going to do one velocity under review. We'll have a couple to check. So what in the world are we being asked for? It looks like it says we're trying to find how far an object has fallen, right? And it says an object after it falls is h feet. In other words, this is asking us to find h or solve for h. And we're being asked to do that when v is equal to 136. It looks like in our problem, we're given a value for g, and that is 32. So now that we have established what we're looking for and all of the values that have been given for us, right? It looks like we're missing h. So perfect. We need to solve for h. Let's get it done. All right. So I've got the formula. V equals 2gh. We've said that v is 136. 2, we know that G is 32, but we don't know H. So our task now that we've substituted those values in is to solve for H. Let's do it. First thing I need to do, right, I've got a radical, it's isolated. I need to get rid of it, right? The way that I'm going to get rid of that is by squaring both sides. And I'm also going to go and multiply this 2 times 32, right? That's 64H. We're going to square that. I got out my handy dandy calculator, and I found that this is 18,496 when I squared 136. Squaring the square root of 64H gets rid of my radical that I had there, my square root. And my last step for isolating the variable H is going to be to divide both sides by 64. The 64's cancel because 64 divided by 64 is 1. And if I divide 18,496 by 64, I get 289. All right, we got asked this question, right, in a context. I would like to answer it in context, right? It has fallen. $289 feet. And there you go. So next class, we'll have you guys do some problems like this. You'll have the solution, or you'll have the answers in hand, so you can check yourself, follow these as examples. Thank you guys for watching. I hope that you're having a fantastic day, and if you're not, I sure hope it gets better. Take care of yourself.